Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at irrational numbers in algebra. Specifically, we're looking at solutions of equations and inequalities. So let's look at this inequality here. So that's very similar to the equation 2/5 minus 0.3x equals 1. This is an equation because it has an equal sign. This is an inequality because I've replaced the equality with an inequality. So this one has one and only one solution. This one, it turns out, will have infinitely many solutions. So we know how to solve equations like this. You would just subtract 2 over 5, divide by minus 0.3, and so on. So the idea that I want to get across is that in this equation, each of these numbers called coefficients is rational. Now this is a linear equation because the x doesn't have a power attached to it. So what that means is that this can be solved using the 4 operations: addition, subtraction, multiplication, and division. It turns out if you add, subtract, multiply, or divide any two rational numbers, the result is rational. So we can tell just by looking at this equation, because it's linear, because each coefficient is rational, the solution to this equation will be rational. So if we were to go and solve this, we would subtract 2/5 from both sides, and then we'd divide each side by minus 0.3. So we'd actually get x equals minus 2. So just as we suspected, we got a rational answer. So how would you solve this inequality here? Well, it turns out you follow the same steps. You undo what's been done to x in the opposite order to BIDMAS. So we're going to subtract 2/5 first. But there's just one difference. When you need to multiply or divide both sides by a negative, you reverse the inequality. So here, once again, to get x by itself, I need to divide this side by a negative 0.3. It turns out in inequalities, if you are dividing each side by a negative or multiplying each side by a negative, you need to reverse the inequality. So here we get x is less than or equal to minus 2. This has infinitely many solutions. Literally any number less than or equal to minus 2 is a solution to this. Any number less than or equal to minus 2 will make this a true statement. So because there are infinitely many solutions, we'll display them on the number line. So if 0 is there, we've got -1 and -2. And of course, the number line goes on forever. So -2 is here. We'll shade in the circle and point to all of the numbers less than or equal to minus 2. This just shows you all possible solutions here. So when you're graphing inequalities on a number line, you use a shaded circle if it includes that value. This tells us that minus 2 is included. It is a possible solution. And then if it excludes it, you use an open circle like that. All right, so let's look at this inequality here. So it turns out it has irrational coefficients and also a rational one. So it's harder to tell whether the final solution will be rational or irrational, because when you multiply, divide, add two irrational numbers, sometimes you get a rational answer, sometimes you don't. But we're going to solve this in the same way we did there. Undo everything that's been done to x. We're not going to do it different just because the coefficients here are irrational. So what we're going to do is we're going to add 2 to both sides. So I'm going to leave it in exact form, √7 plus 2. I'm not going to write this as a decimal because that'll introduce an error. So the way I undo timesing by √6 is I divide each side by √6. So I'm not reversing the inequality because I'm not dividing each side by a negative. This is my final answer. √7 plus 2 over √6, that is the exact answer. And it turns out that this is irrational. So it is about 1.9. So it's just less than that. It's like 1.89662. It goes on forever because it's irrational. So if I want to graph this on a number line, what I'm going to do is just estimate. So if 1 was here and 2 was here, it'd be just less than 2. So I'm going to put it about there. So because this time we want all the values greater than that, we point over this way. So literally any value greater than this will satisfy this inequality. All right, so we've looked at linear inequalities and their solutions. Let's now look at non-linear inequalities. So let's first look at x squared is less than or equal to 9. We're going to look at solving that inequality. Let's though look at x squared equals 9. So you might have an instinct to square root each side, but that will only get you one of the solutions. There are two solutions here, positive 3 and negative 3. We write it like this. X can be positive 3 or negative 3. So what does that mean for x squared is less than or equal to 9? Well, it means that positive and negative 3 are solutions to this because 9 is less than or equal to 9. So because these two are solutions, I'm just going to mark them there. So we essentially have three regions of this number line, here, here, and here. Let's see which of those satisfies this inequality. So let's try something like negative 4. Well, negative 4 is not a solution to this because negative 4 squared is 16. 16 is definitely not less than or equal to 9. And that's exactly the same for positive 4. But it turns out if you square any number between these, you will have a solution. Negative 2 is a solution because negative 2 squared is 4. 4 less than or equal to 9 is true. So we are including the values negative 3 and 3, so that's why I've done a shaded circle and we just have a line between them. The solution here is written like this. X is between and including negative 3 and 3, any such number. So how would we solve something then like x squared is less than or equal to 10? See, here is where it diverges. On the previous slide, I showed you that when you have a linear equation, if all the coefficients are rational, you get a rational solution. That's not the case when a squared is involved. See, if you add, subtract, multiply, or divide rational numbers, the answer is rational. But that's not the case when you square root. If you need to undo squaring, you can square root a rational number and get an irrational answer. And that's what happens here. It turns out if I want to solve the equation x squared equals 10, even though the coefficients are all rational, here the coefficient's 1 and the constant term's 10, even though they're all rational, the solutions here are irrational. You get x equals plus or minus the square root of 10, which is irrational. So what that means for this inequality is that x would be between negative root 10 and positive root 10. So we write that like this. X is between and including negative root 10 and positive root 10. These are less than or equal to signs because this was a less than or equal to sign. So x is between these values. Any number between these two values will be a solution to this inequality, but it's important to note that when squareds are involved, when it's a non-linear equation, you can have rational coefficients and irrational solutions. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.